Now we're looking at the Java REST client. You're going to be building very shortly an Android client of the donation web service. But before you do that, it's useful just to look at a simple Java application without the Android infrastructure to explore just how we can contact a REST API without the distractions of a full-on mobile application. So there's a lab for this one here. This one takes you through the construction of a Java REST client, just going back to Eclipse. So we're going to leave Android Studio aside for a while, go back to a simple Eclipse application and just build a pure Java application that interacts with our donation web service. So let's have a look at how we're going to build that. This talk is basically a guided tour through this lab, looking at some of the principles. So what I'm trying to do, we've got a donation service written in Node. You've been building the API for a few weeks, you've been testing the API. And we'd now like to build, as an experiment really, kind of a throwaway, this application here, which is a Java application to interact with that service, to maybe list candidates, make a donation, etc. We're going to build it in Java because obviously Android is in Java, but we're going to decouple it from the Android SDK just so we can get a good handle on the library we're using to interact with the REST service. We can debug it, perhaps independently of having to run an emulator or running on an actual phone. And by the time we get around to using Android itself, we'll have a fairly good idea of how REST clients work when implemented in Java. So this is the application you're going to be building here. It's good old Eclipse workspace. The source for the application, we'll step through that now gradually here. There is a general API interface here. It looks like we've got a mirror image of our model here, which is correct. And then our main driver, which is just a Java console application. Also notice we have in here some libraries. JSON, retrofit, and a variety of other downstream dependencies. You will be including these dependencies into the Android app as well. And in fact, you'll be bringing over some of the models I've just mentioned above. So this is a good test bed before you take a leap into Android. These are the Java classes we'll be using. You'll notice they mirror fairly closely the Mongoose models, but they're in Java. They contain the same fields, contain a standard constructor. So they're kind of mirror images. If we just confirm that. JavaScript on the left here, our candidate schema, and looking at our candidate model, our donation schema in JavaScript, and our donation model. Notice in our donation model for the moment we don't have representations for the donor and the candidate quite yet. We've just included the base data, the ID, method, and amount. We'll come back to that in a moment. These two classes here, Donation Service and Donation Service API, are wrapper classes. You'll be bringing these directly into your Android app in the next Android session. Their job is to, in the client, build up HTTP request and send it to the server. These are the libraries I mentioned. We're using a library called Retrofit. This is a well-respected open source library for exactly this purpose, interacting with REST services. It's designed for Android, but of course it's just Java, so it works fine on a standard Java console application we're building here. Retrofit and Volley are similar enough. I think you may have been looking at Volley also independently of this. This is the library itself. Effectively, it means we're declaring an interface, and in that interface we are annotating it with a notation that indicates that this is the client of a GET request. Once we put in those annotations, then this particular method is not implemented by us, it's generated by the library. So we'll see that in action in a moment. Once we've got our interfaces defined, then we have merely to find a way of creating the appropriate client objects to proceed with our interaction. This is an example here of how you might assemble a service to access GitHub. And then we're calling that service in standard Java manner, as you can see in the last line here. So it's quite interesting how it's done. Lots of behind the scenes work inside the library itself, but quite a clean surface area. So what you have to write is reasonably straightforward, and that's the key really. Here is our donation service interface, and you can see here it matches the routes we've already devised in Node in our Happy application. That one-to-one mapping here of each of the endpoints. An example, get all users here matches this route we have defined in our Node application. Similarly, if we're trying to implement a post command, create user, you can see create user here, then this matches this route here. If we've got IDs embedded in the routes, for instance when you're creating a donation here, then it follows a very similar pattern to the way we set it up in Node. So just pay close attention there to this signature of this method here for a moment. This is the annotation, and you can see it's pretty close, identical really, to the path specified below. But also look at how we are composing the parameters to this method. We have another annotation, ID, and another annotation, body. And our body annotation is actually the donation we're creating. The whole point of this framework retrofit and how we're using it is to keep it very high level and very logical and transparent, such as you can compose an interface like this just by inspecting the routes. And that's exactly how we've done this. Also notice that this is an interface, and as you know, interfaces are just specifications, you don't implement them. However, the magic of our library is that we never implement this. It is generated by the framework itself. So this is all we need to do to get the wrapper up and running. We have a second companion class to generate what effectively is the client-side infrastructure to operate this service, and we're calling this our donation service API class. First thing we're doing here, you notice, is we're declaring an instance of the service object we've just described. That is, this thing is an instance of that. And then in our constructor, we're manufacturing that object. It eventually exists down here. That is, we're creating a service object that we can invoke those methods on we just looked at to interact with our Node application. Now the parameters you can see here, we've got a service URL. You might be able to guess what that is. That's going to be localhost, or it could be the URL of the app as deployed on Zeit or on Heroku or on Glitch. This is a standard factory method we use for JSON parsing, so we'll always have it like this, and then we finally trigger a build. Once we've done all this, we will have established inside in our donation service object, we'll have this service object that we can start to use. And here is the implementation then of our wrapping at this higher level. So we see here we've got get users, get all candidates, get all donations. These methods are what our client will use, and they will be invoking the service methods we have just defined. So if we look at this example here, for instance, that's the get all users method we just invoked. It's giving us back a call object, and that call object we trigger by calling execute. Once the call object returns, we're able to recover all the users by invoking users.body. Now it looks a little bit complicated, and I guess it is, but it's always the same. If you look at these three methods here, all they're doing is creating a call object, executing the call, and returning the body. And that's the case for all three methods, and they always look like this. If we look at it again in a little bit more detail, let's take the first one, get all candidates. First thing we do is we assemble a HTTP request. And that's exactly what's happening in this line here. We're assembling HTTP request. That request object we're calling call. We're not invoking anything yet. We haven't triggered any network traffic. We haven't contacted the service. We're just building up the request. Second thing we do is we dispatch the request and wait for the response. That's what's happening here. We're saying call that execute. Now we're going to trigger an invocation. It's going to be sent to the server, wherever that is. We're going to wait. We're blocking. And we're going to sit back, hopefully, to get our response. And our response, you'll notice, will be a response object. And the response object is encapsulating higher level domain objects we're expecting to be returned. In this case, we want a list of candidates when we get all candidates. Finally, when we get the candidates back, they will be in JSON format. We're in Java, not JavaScript, so JSON isn't as easily accessible to us, but our library wraps it up very nicely. And we will see that here we'll be returning, well, we're returning exactly what we wanted, which is a list of candidates. So all of our REST interactions will follow this pattern more or less. And it looks complicated at first, but once you get into the flow of it, it's reasonably elegant. Notice one thing before we move on from this. This is a blocking call. The world stops while we're waiting for the response. As in Node development, Android development also will not appreciate blocking calls, particularly blocking calls on the main thread. So when you explore this example in Android context later on, there'll be a slightly different way of triggering this invocation. I'll leave that to the Android session to explore. Okay, here's another example where the same thing again, we're creating a user this time. So again, the pattern is assemble the request, trigger the request, get the return value back. In this example, we are passing over information, or passing over a new user, and we just pass that on when we create a request here. Again, notice that this is made possible by the interface we've defined here. So here's how we can kick it off then. Create a new donation service object. So here we are specifying where the service lives, the URL. And then all we're doing is give me the candidates, give me the users, give me a list of all donations. It's very seamless, and this is very attractive really, to be able to work up at this higher level inside Java. It's as if we are talking to our local model when we're not really. We're interacting with the remote service. Now we do have, remember, donation and candidate and user model objects, or rather Java versions of them, inside our Java application. Now let's look at printing them out. So we've got a simple little pretty printer here available in JSON. So once we configure that and we request all donations from the service and pretty print them, then we should be seeing this here in our console inside Eclipse. And notice it's echoing them out there just like you might echo them out inside JavaScript itself. This, remember, is the Java object that we have created. It's a shadow of the remote object, or a copy of it, allowing us to have a client-side version built up once we request it. Now what about object references? So we mentioned this at the very start. Our donation schema has the amount and method. It also has the donor and the candidate. When you go through the lab here, we're ignoring those initially, and when we display in the client all the donations, let's say, we're getting this here. We're getting the ID, amount and method, and there's no donation. Sorry, no donor and no candidate. We have apparently just ignored these. They are there on the server. We didn't delete them, or we didn't eliminate them. They are there. We're just not receiving a copy of them. Now how do we do that? Well, again, the library we're using, and this is a massive improvement from the way this was done before libraries like Retrofit were introduced. We just bring in objects in the client to represent those references. So we incorporate a user object called donor and a candidate object called candidate. Just by bringing in these two fields, and of course we have these classes client side, and if we have the correct populate triggered in the server, then we get exactly what we wanted here into the client. That is, we get populate into the client the sometimes called denormalized versions. That is the actual object values themselves. Now that's a really very convenient and seamless way of doing it. If we just have a look at the code for a second, I could run the server here. So I'm running the last version of the lab. It's up and running, Mongo is running, and I can make donations and so on, see the reports. This here is the result of running the lab. If I run the application again here, then you can see down here I'm just contacting the service, getting a list of users, getting a list of candidates, and I'm even making a donation here to show that it can happen. We might see the donation is being made here. That's the donation generated by the donor. Notice that donor is blank. That's something we'd have to consider when we get into the Android context later on. And you can debug this if you want. Let me drop a breakpoint just here. And if I run under debug, I'm stopped here. I can step over, create a donation. I can have a look here at the donations that I might have just retrieved here. And these are the donations, including the one I've just created. Run on again to conclusion. I could also debug in the client side simultaneously. Let me drop a breakpoint in make donation over here. Debug the server. So now it's running again. Perhaps debug the client at the same time. Let's try that. Now I'm about to make a donation, which will be on this line. So as soon as I step over the next step, I should halt here. We can see what's going on. Make a donation, stopped here. Now we're over on this side and we're having a look at the donation that's arrived in, and we're going to proceed with creating the donation. If we pause too long here, you get a timeout over here. You might see that happening. That is a timeout on the retrofit library. We could extend the timeout if we wanted. If I run on full speed here again, and maybe I debug this again just to see it a second time. Step over, breakpoint has been hit. Run on full speed, and now I'm back debugging on this side again here. You can see possibly the reason we're using Eclipse here and using a simple Java application rather than going full on Android, because debugging is very simple. I can debug both sides without major hassle. You can do this on Android too, but you will probably a lot slower experience as you're powering up simulators and all that paraphernalia. Whereas here we just have a simple Java app and a quite easy to manage execution environment. That's our user model. This is our donation. This is another version of donation with the extra 2 fields in it. We're calling it donation complete. So we can keep both of them there if we want. And this is the service we just spoke about. And this is the wrapper that uses this service to make the calls. Okay, that's all part of this lab here, which is in the donation service, lab 19. So we're having a go at that now, I think. And once you're done, you will be in a better position to tackle integrating this pattern into your Android apps using the same libraries in your next Android installation. Okay, that's it. Have a go at that, so, and see how I get on.